Hello everybody and welcome back to another visual pattern challenge. Here's our visual pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? That's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, I think this one is pretty tricky. It's even tricky to get a sense of sort of the visual pattern here. I mean, it kind of looks like almost a circle that you'd make in Minecraft getting bigger and bigger, or maybe a sort of a diamond pattern. How can we get some visual intuition about this to figure out step 4? I guess, what we have in the middle here is this rectangle, so that's easy to see, and that's a 2x3 rectangle with a couple of pieces on the top and the bottom. And in the step 2, this rectangle in the middle is now 2x5. So this was 2x3 and this is 2x5. But look, the whole of step 1 is sort of broken off and put on either side, right? So this would be the top bit here and this would be the bottom bit here. Let's see if that follows again in the next one. So here we have, that's 2x7. And then, we have, so this is, if you cut this in half, this would be a row 5, 3, 1, 5, 3, 1. So if I were to predict step 4, the rectangles in the middle are 2x3, 2x5, 2x7. So I would expect to have a 2x9 rectangle in the middle. And then we'd have all of this on the top. And what's that going to be? All of this on the top, 5, 3, 1. So 7, 5, 3, 1, right? The whole half of this, 7, 5, 3, 1, and then 7, 5, 3, 1, coming off like that. Okay, so that's my prediction for step 4. Let's add all that up. Let's see, 18 and 14 and 6 and 2. I think that's 50. So my prediction for step 4 is 50 squares. So this is getting big pretty quickly. Pretty sure it's not a linear pattern. Probably quadratic. Maybe something else going on. Let's take a minute to sort of analyze the numbers here. So we'll make a chart with the step number and the number of squares. So in that first one we had 8. And then it's a 2x5, so it's 10 with the 8 from the previous step, so that's 18. And 3, 2x7 is 14, and plus the 18 from the previous step would be 32. And in the fourth step, we're predicting 50. So let's take the differences between each step to analyze this. So 18 minus 8, that's 10. And 32 minus 18 is 14. And 50 minus 32 is 18. So we don't get a constant in the first set of differences, which means it's not linear. If we take the difference of the differences, 14 minus 10 is 4. And 18 minus 14, also 4. So this is where we're getting a constant in that second order difference. And that means it's a quadratic. And the coefficient of our leading term is half of this constant. So we're going to have a 2x squared somewhere. Now, how to approach coming up with an equation here? It seems like you could, look for 2x squareds in every one and then block those off and see what's left. I don't think this particular visual arrangement gives much of a good sense of that. One thing you might notice is that really, if we look at the halves of these, they are the odd numbers in sequence. So we've got a 3 and a 1 on top and a 3 and a 1 on the bottom. That's 4 and 4. In the next one, we've got a 5, 3, 1 on the top. That's 9. And a 5, 3, 1 on the bottom. That's 9. So what we're seeing here is this pattern. When you add the successive odd numbers, you get the square. So each half of these is a square. And I think that's good insight if you manage to remember that and notice that pattern of the successive odd numbers being added together here. That's a bit of a stretch. You might not have seen that. Another way to approach this is to look at your numbers and see if anything suspicious pops out here. And one clue is this 2 in the x squared. So you may want to think of these as divided by 2. So if we made a new chart with step 1, 8 is 4 and 4. And in step 2, 18 is 9 and 9. And in step 3, 32 is 16 plus 16. And you can see we've got perfect squares there, just 2 of them. However, 2x squared is not the equation because in step 1 we've got 8, and this would be 1 squared is 1 times 2 is 2. These 4's are 2 squared, so it's actually the step number plus 1. So I can write this equation then as 2 times the step number plus 1 quantity squared. So let me show you how that would work out. In step 1, I'd put in a 1 for x. 1 plus 1 is 2. Square that, I'd get 4. Multiply it by 2, I'd get 8. If we try that for step 2, 2 plus 1 is 3. Square that, we get 9. Multiply that by 2, we get 18. So you can test this out with the other ones, but that, I think, is our equation. Y equals 2 times x plus 1 quantity squared. You can definitely FOIL that out and distribute the 2. I think you'd get 2x squared plus 4x plus 2. I'm not going to do that this time. I think this is actually a more convenient way to use it because we're going to plug 43 in here, and it's just easier to plug 43 in once rather than having to plug it in twice when we FOIL this out. So to get the number of squares in step 43, we're going to have 2 times 43 plus 1 quantity squared. So 43 plus 1 is 44, and 44 squared is 1,936, and doubling that, we get 3872. So I think there are 3,872 squares in step 43. Do you agree? How did it go? Did you get 50 for the next step? I think this was a pretty difficult pattern to understand visually. Well, let me know. Thanks, everybody.